Today, Jonathan and I will be reviewing the topic of Riemann sums, particularly left and right endpoints. This is a very general way of thinking about approximating the area under a curve by finding the area of representative rectangles that either extend above the graph, below the graph, or a combination of both. The left endpoint method takes the height from the left side of the interval times the width of the subinterval, while the right endpoint method takes the height from the right side of the interval times the width of the subinterval. The first step to solving a Riemann sum problem is to determine the width of the rectangles. You do this by dividing b minus a, which is the length of the interval, by the number of rectangles, which is represented by the letter n. This breaks the area into subintervals of equal width. Find the f of x value, or the height of the rectangle, for each left-hand or right-hand value of the rectangle. Then multiply that height at each x by the established change in x, which is the width, to determine the area of each rectangle. Then add those areas together to approximate the area under the curve. If the rectangles are circumscribed about the curve, meaning they extend above the curve, then the area of the rectangles is larger than the actual area under the curve. While if the rectangles are inscribed, meaning they are under the curve, then the area of the rectangles is smaller than the actual area under the curve.
Okay, so the example problem we're going to do is the function f of x equals x squared. We're going to do it on the interval of 1 to 5 using 4 rectangles. So here's our table that we have with our different points. That could actually be f of x. So 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, 5, 25. So to start, using our left endpoint, start at your first point in the interval, which is 1, which is equivalent to our a value. Go up till you hit the graph, and go over to the next point. So we have our rectangles drawn. Now using the equation, b minus a over n, 5 being our b value, 1 being our a value, the n represented by the number of rectangles. So we end up with 4 over 4, which equals 1. It's pretty self-explanatory in this case. So the bases of all these rectangles are 1, and because we know our f of x value, we then know the height of them. So 1, 4, 9, 16, and the 25 would be up here if we had another rectangle. So from this we can get to the area of this is 1, 4, 9, and 16 consequently. Add them together, 1 plus 4 is 5, plus 9 is 14, plus 16 is 30. So using a left Riemann sum, the area under the curve for the graph of x squared in the first quadrant on this interval 1 to 5 using 4 rectangles is 30. And again, as we can see, because of this space right here, it is in fact the underestimation, which is our inscribed. So next we'll do our right Riemann sum using the same exact function, f of x equals x squared, in the interval of 1 to 5 using 4 rectangles, staying again in the first quadrant. A trick with this one is to start at your b value within your interval so that you don't screw up your number of rectangles that you need to use. So if we go start at 5, again going up until we hit the graph, then going over until we get our 4 value, which is right here. Then from here, right where 4 hits the graph, go over again, draw down to the 3, so on and so forth. If we do our same equation of b minus a over n, we get 4 over 4 again, which means 1. So all the bases of these 4 rectangles is in fact 1. You can tell it from the interval on the x-axis. And then we're going to use our points that we have way over here in our table. So from that, we can get that the height of this rectangle is 25. So 1 times 25 is 25. 1 times we have 16 over here is an area of 16. 1 times 9 is an area of 9. And 1 times 4 is an area of 4. So then all you have to do at the end is add all these up. 4 plus 16 is 20, plus 25 is 45, plus 9 is 54. So the area using a right Riemann sum is 54. And what we can see from here, the difference between 30 and 54 is this area right here, and all these rectangles that is above the graph. giving us an overestimation, so it's circumscribed. And that's the difference between left and right Riemann sum with x squared. Alright, so as Mr. Crock would say, we have some slight nuances, things of that nature. We learned earlier when we have our left endpoint triangles on our original function f of x equals x squared, that would be inscribed. So it would be an underestimation. However, that's not always true. An example of this is, say that our function given is f of x equals negative x plus 3. So pretty generic graph of it would be something like that. Say we're on the interval a to b. Here are the points on the graph. So if we go to the left endpoint, we go up to the graph and go over. As you can see here now, there's area above the curve, meaning that using left endpoint is in fact circumscribed instead of inscribed. If we use the same function and go using right endpoint now, so still in the same interval of a to b, draw up to the graph, go over. And now we can see that there is an area that is not accounted for underneath, meaning that right is now inscribed instead of circumscribed. So don't get into the habit of associating left endpoint or left Riemann sum with being inscribed and right being circumscribed, because it's all dependent upon the slope of your function, and it changes from function to function.